Hey, how's it going? I'm late. I am late for the Leetcode competition. God, it's like every chopper in a 50-mile radius driving past my house in unison. Apparently. Should I start the video over? No, it's fine. I'm late, remember? Okay, contest. Jump game 4, huh? Have I done this before? Well, I don't have time now. I thought maybe I'd done it before. Okay, contest. Limit occurrences in sorted array. You are given a sorted integer array nums and an integer k. Return an array such that each distinct element appears at most k times while preserving the relative order of the elements in the array. Okay. Let's see here. C of I plus equals 1 if C of I is less than or equal to k, then R dot append I return R. Okay, let's see here. Yeah, so 1 1 2 2 3 1 1 2 2 3 and then 1 2 3. Okay, cool. Accepted. Super. Alright, Q2 password strength. Ooh, entropy. You're given a string password. The strength of the password is calculated based on the following rules. 1 point for each distinct lowercase letter, 2 points for each distinct uppercase letter, 3 points for each distinct digit, 5 points for each distinct special character from the set. Boom, boom, boom. Well, alright then. Each character contributes at most once, even if it appears multiple times. Alright, so S equals set of password. Oh, cool. That makes my job a little bit easier. So, yeah, for I in S. God, stop. I in S. If I dot lower equals I and I dot is alpha, then 1. If it is alphabetic, then t plus equals 2. Otherwise, if that is digit, then t plus equals 3, and else t plus equals 5, right? Return t and roll. 11, 11, 11, 11. Sweet. Next question. Q3, minimum operations to sort a permutation. You're given an integer array nums of length n, where nums is a permutation of the numbers in the range 0 to n minus 1. Oh, okay, so there's no duplicates. You may perform only the following operations. Reverse the entire array. Rotate left by 1. Move the first element to the end of the array and the rest of the elements left. But yes, I know what rotate left by 1 means. Return the minimum number of operations required to sort the array in increasing order. If it's not possible to sort the array using only given operations, return -1. Oh, shit. left by 1. Okay, the question is it already a rotated array? Because the relative order of the circular version of the array isn't going to change. The reverse and rotate thing was messing with my head, but yeah. How big can the array be? Yeah, now, if you rotate from the right and then reverse, it might save you a little bit of time. Yeah, let's figure it out one way first. So, CNT equals 0, and then we're going to say, okay, it is a permutation of numbers, so there are no duplicates. And we know what the cutoff point is. Okay. Which means if we can find the 0, we can tell if it's in order. Circular. So we need to find, where is 0? That's what we need. Where is 0 equals -1? And then we're going to say for I in range length nums, and then if nums of I equals 0, then where is 0 equals I, and then break. Right? So it's either going to be forward, it's going to be backwards, or it's going to be invalid. There's no other way to to deal with it, so we will see. So for I in range length nums, yeah. Well, so if nums of I plus where is 0 mod length nums does not equal I, then is not forward. What the hell? Camel case. Is not forward equals false. That is the worst variable name I've ever made. INF is false. INF is true, and then break. Right? Yeah, so if length of nums equals 1, well, then return 0. Is lesser than or equal to 1, then return 0. So we're not even going to worry about if it's smaller than that. Yeah. So if it's 2, yeah, there might be a case where we want to reverse, but generally speaking, yeah. I think 2 might be the only case where reversing I feel like 2 might be a special case. If length of nums equals 2 and nums of 0 equals 0, then return 0. If then the only other case is 1. I just, my brain is telling me that is a special case. Okay, so we're going to have to reverse eventually, right? But let's look at the case where it is in order. And I don't think we need a special helper function. So yeah, if Well, I don't even remember what it stood for. If INF, yeah, and not where is 0. Then return 0. It's already sorted. If INF otherwise, then we have 2 choices, right? Yeah. Just rotate left. Cost equals where is 0, and then rotate right cost. Yeah, this is going to be flip, and then move, and then flip again, right? Once it's done. So yeah, what is that going to look like? So it'd be like 1, no, it would be 1, yes, 1, 2, 3, 4, 0, right? And so length of nums is going to be equal to 5, right? And then nums, where is 0 is going to be equal to 4. And so what we're going to do is we're going to, hold on. Let me make sure I don't have this backwards. Rotate left 1, so boom. And we don't want to do that. We want to flip it first, then rotate, then flip it back. Okay? So it's going to be, I think the battery is dying on my keyboard. Yeah, that'd be great if it dies in the middle of the competition. Rotate right cost is going to be 2 plus, we need to know the distance from the end, so it's going to be length of nums minus what? Well, minus where is 0, obviously. Yes. And then we would return the minimum of the rotate left cost and the rotate right cost, which I just realized. Yeah. Okay, it's going to be a little bit weirder if it needs to be... Is it going to be a little weirder? Because I feel like we're absolutely going to have to rotate it once. Yes, but if we rotate it, we can rotate it at the end if it was quicker to go the other direction. So, yeah, let's fix. Oh my God, I might need a battery. Hold on. Okay, I'm back. Hopefully that's what was wrong. Okay, cool. So let's figure this out. It'll be basically the same thing, right? So we start off with INF false. And then this is going to be inverted. So where is 0 minus I? Okay. And then yeah. And then we use mod, and unlike Java, mod actually works in Python. So yes. Now, so we're going to have basically what? The ideal case would be like 3, 2, 1, 0. Then this is going to be a single reverse operation, right? So yeah. So the rotate left cost is, let's try to figure this out. So length is 4, and where is 0 is 0, 1 is also 4, yeah. Shit, did I do that wrong? Did I do that wrong? 0, 1, 2, 3, 4. The length can't be... What is wrong here? Length is 4, 0, 1, 2, 3. Yeah, I just typed the wrong number. Okay. So the rotate left cost is obviously 1 plus something with what is 0. And it's going to be, the further it is, the more we have to rotate it. So a rotate operation, where is it? Rotate left by 1. So this goes to the end. So it would look like this, right? And that would be 1. That would be 1, and that would be 0. Okay, this is melting my fucking brain. Shit. So, where is 0 equals 0, 1, 2, 3 implies a cost of 0. Fucking loud ass vehicles. Okay, where is 0? Is 0 implies 1? Is this making sense? I'm about to look out the window and figure out what they're doing. I think that they're just driving to the top of the street and back. Okay, so this is 1. So it would be like 0, 1, right? So it's 1 implies 2. And then 2 implies 3. So it almost seems like this is a special case. Yeah, it does. It is a special case. So if, where is 0? It's not a special case. So it's 1 plus where is 0 mod length nums, right? So it's always 1 greater than the location, unless it's at the very end, in which case it's 0. That's the rotate left cost. Now the rotate right cost, we're going to have to flip first, but we're not going to have to flip again later, right? So let's see. Rotate right. So we initially flip. It's just 1. Because we don't need a second flip. We're guaranteed to have to flip. So the rotate right cost is exactly the same, except we flip first. So it's going to be 3, 0, 1, 2. Well, no, we don't have to do that. We can just figure out what it would be rotating the other direction. We don't have to actually initially flip the array. So after we flip it, we just need to get this to 0. So well, we need to get it to the last spot. I think it's length of nums minus 1 minus where is 0, right? Let's do it. So the ideal case is 3, 2, 1, 0, right? And that's where is 0 of 3, and this is where is 0 of 2. And then if we put this here, then it's where 0 is 1, and then 0, 3, 2, 1. So where 0 is 0, and this implies a cost of, move this to here, so this is the cost of 1, which is exactly what I said. Length of nums minus 1 is 3, minus 2 is 1. And then this is a cost. This should be 0. So this is 1. This is 0. Two, 3. So this is a cost of 2. And this one, you'd need a 1, 2, 3 to get it to the end, right? Zero, 1, 2, 3. Okay, it's right. 3 minus 0 is 3. 3 minus 1 is 2. 3 minus 2 is 1. 3 minus 3 is 0. All right. What? Why is my mouse not working? Okay. Yep, that is right. And then otherwise it is -1. 0, 1, 1. Oh, God. Zero, 2, 1, right? And this is saying it's a cost of 2. So the 0 has to come here, and then it has to be reversed. That is 2. We need to find the path that it went. Which path did it go? Well, 0, 1, 2, and then 0. No, you couldn't go that way. There's only one way it can go. Where are we getting 0 from? Let's see. Print path 1. No, we can do that. Rotate left, rotate right. Okay. Have to figure out what it's doing wrong. Oh my God. Okay. Path 1, 0, 5. Rotate left cost is where is 0? Yes. Oh. This is not in order. Cannot access local variable rotate right cost when it is not associated with value. It is not associated with a value. Two, two, -1. All right. Accepted. Oh, sweet. I was a little worried there. I actually kind of need some water, so I will be right back. Okay, I replaced the batteries in my mouse. Seems to be working. And I got some water. So, let's look at the last problem. Number of pairs after increment. You're given two integer arrays, nums1 and nums2, and a 2D integer array queries. Each queries of I is one of the following types. 1 xy val, add val to every element in nums2 x through y, presumably inclusive. 2 tot, compute the number of pairs jk such that nums1 of j plus nums2 of k equals to what the fuck? Okay. Return an integer array answer where answer j is the number of pairs for the jth query of type 2. Well, all right then. Okay, so you modify the data and then you and it's probably 10 to the 5th, so you can't brute force it. Add val to every element nums2 x through y. Okay. Okay, how many total queries can there be? There can be a shit ton of queries. How would I do it if you couldn't modify? Well, if you couldn't modify, then it would be trivial to just I mean, it would be my inclination to sort initially if I were just trying to figure out the combinations. However, you can't sort if you need to be able to access things based on their indices. I don't know if I know how to do this. Alright. value total nums I 10 to the 5th. Is there some... No, it's like you have to actually know the values. You have to actually know the values. It's one of those things where you have to have the data sorted in two different ways, basically continuously. Queries.length. What is queries.length? How many queries are there? If it's like super low, no, it's not super low. Well, I'm not going to sit here and waste a bunch of time on this. I don't know any way. I don't know any data storage mechanism that is going to allow me to keep these in sorted order while changing their values like this. What would happen if you sorted them? Well, it doesn't matter. I mean, whether I count the sum as a post step or a pre-step, either way, implementing it is going to be n squared. So it doesn't matter if the n squared penalty is on the addition or whether the n squared penalty is on the query lookup. Yeah, but you don't need to know the order for calculating if sums are valid. You're right. I could look at every unsummed value. The problem is that there's no guarantee that any of them overlap, which means it would be 2 raised to the number of queries, different combinations for the sum difference if you were trying to like be sneaky about it. And any solution where I end up having to look at every single pair runs into the same thing. So it's like a double n squared. Compute the number of pairs. I mean, I could do a naive implementation, but it wouldn't be fast enough. It just wouldn't work. Rereading the problem here, see if there's like see if there's some trick. There's just something hidden that helps me. Add val to every element in nums2. So nums1 does... We could sort nums1. In fact, we should sort nums1. How big is nums2? What if we like broke it off every single time? Nums2 can be big as shit, man. But we can look through 5 times 10 to the 4th. We just can't look through 5 times 10 to the 4th times 10, 5 times 10 to the 4th. Right? What if we implemented modifiers? Like an accumulate? Yeah, exactly like an accumulate. We're going to calculate that every single time. Yeah, why not? Oh my god. 45 minutes, this might actually work. This is really dumb. Okay, let's see here. nums1.sort. Can we reverse the accumulation? I've never tried. Reverse accumulation equals, let's just start nums. Here's how we're going to do it. Reverse accumulation equals nums2.copy, right? And then we're going to say RA builder equals list of accumulate of nums2. Is that what we want? And then we want to know the difference to arrive at the final result. Is that the right way to do that? Let's go RA of 0 times length nums2. Are they the same length? It's okay if they're not. They don't need to be the same length. Okay. And then we'll have an accumulator value of 0, and we will say for I comma v in enumerate nums2, right? And then ACC plus equals value. And then we want this to accumulate to the value that we are actually at. So the accumulator is going to be too big, so we're going to need an offset. So we're going to have desired value equals v, and we're going to decide what the accumulator is, right? I'm trying to not say something I'm going to regret, but that vehicle is really bothering me. Okay, desired value equals v, and we have an accumulator, so we need to modify the accumulator. So if the accumulator is too high, then it needs to go down. So modifier equals desired value minus ACC minus desired value. If desired value is the higher desired value is, so if we want 1,000,000 and accumulator is 0, then yeah. And then that is what we write here. RA of I equals modifier, right? Then we're going to say test array equals list of accumulate of RA and assert test array equals nums2. Right? Print it worked, and then return, I don't know, nothing. Assertion error. Well, that sucked. Print test array. Yeah, sorry. So the... I'm such a moron. Oh my god. Accumulator is just the last value. Idiot. Idiot, 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 idiot. Why did I make it so hard? It doesn't matter. Okay, I have 40 minutes. Let's see here. 3, 4. Okay. Wait, I want to see the actual accumulator array, though. This is what is going to empower us to actually make these. So 1, 2, 5, 1, 2. Okay. Okay, that is correct. All right. So let's test the modifications. List accumulate of RA. Right, and we don't even need it sorted. We don't need it sorted. Nums1 set equals set of nums1. This is not even going to be very difficult. Okay. It's just going to be getting these queries right. So the return value is going to be like that, and then we are going to for ARR in queries. Missed. If ARR of 0 equals what? ARR of where's the queries defined? We'll do 2 first. Compute the total number of pairs. Yeah. Yeah. Then tot equals ARR of -1. And we will simply say for I in accumulate RA. Yes. If tot minus I in number 1 set, then v plus equals 1. As simple as that. R dot append v. Right? So each of these queries represents one of these here. Otherwise, assert ARR of 1. No. Of 0 equals 1, and this is going to be the actual modifier, right? So these are inclusive. Nums x through y. Let's look for an example. So 0 through 2. 0 through 2. 0. No, I read that wrong. 0 through 0 by 2. So it is incrementing. So it is inclusive. Okay. So yeah, if it touches the last one, then we'll just need to ignore that, but we can figure that out. So start inclusive equals ARR 1, end inclusive equals ARR 1, no, equals ARR 2, and then the value equals, obviously, ARR of 3. Now, this is really simple. RA of start increment plus equals V, and then if end increment plus 1 is less than length of RA, then it ends somewhere. So it will be end increment plus 1 minus V, right? Yes. I'm a little paranoid. Let's put in a paranoia check here. Paranoia check. So, yeah. So remove me pre-check equals list of accumulate of RA, and then remove me post equals list of accumulate of RA, and then for x comma y in shit. Enumerate is that right? Suddenly forgot what words are. Enumerate of zip of pre and post yeah. And then if I is greater than or equal to and I is less than or equal to an increment, then assert y minus x equals v, right? And then otherwise assert y minus x equals the r, just y equals x, I guess. Yeah. And then that increments that, and it just wants to know the totals, right? So, no. Return R. Yeah, 2, 1, 2. Something's wrong here. Example 2 is output is 1, 3. Oh, shit. Okay. Counter of nums 1. We'll change this to N1C, N1S if it is, and then it will be N1C and N1C of run. So 2, 1, 2, 6, 1, 0, remove, paranoia check, remove. I was nervous for nothing. Okay, so submit. Oh, this makes me nervous. Getting extremely nervous. If this doesn't work, then what is it? Is it malfunctioning? Oh, shit. So it's technically right. It's just too slow. I don't know what to do here, so. See any way to speed it up here. I mean, this is order 1, so obviously this isn't going to be able to go any faster. No, this is order 1. This I mean, I could try something hacky or something. I don't know. Put like it inside of a sum or something, and then just hope that an inner routine just happens to go a little bit faster. That seems pretty dumb. Tote equals 1. Could we use that to our effect? No. It's this. This is where it's timing out. This is the only place that it could time out. This was my trick. I mean, there's just, this was my trick, so. Okay. I guess V equals sum. Will this work with 0? I don't know. I mean, I'll try putting it here, but this just, I don't think this is going to speed it up. It's exactly the same logic. No, you can't do that. That'll start adding things to it. It has to have the comparison. Tot minus I. Yeah. I'll just see if putting it inside of the sum, it just needs to be a little bit faster, right? No, it could be 5 minutes too slow. I don't know. I'm hoping that it only needs to be a little faster, but I don't know. Okay. All right. Yeah, 2126. That's not gonna change anything. This sucks. That was my trick. I mean, I had one trick, and I guess it just wasn't good enough. So, if this could just pass, that would be awesome, but I'm not particularly hopeful because it's literally the same thing, so. Yeah, same one. What if RA hasn't changed? V equals 0, right? So we say V equals this. So has changed equals, well, for the first time it's true. And then when we calculate it, we say has changed equals false, and we put V here. And this is and has changed. Now, if it has not changed, then we set has changed. We have not set it. Has changed equals true. It's almost like we need to calculate only the part that has changed. Is there a way to do that? What if we could like split it up into like 1,000 pieces? Well, no. If you split it up into 1,000 pieces, then calculating which parts have changed starts to become the n squared complexity. That's not going to help anything. Run it again. 2, 2, 1, 2, 6, 1, 0. 2, 1, 2, 6, 1, 0. Maybe there were duplicate yeah. Well, we don't know what the total's going to be, right? The value's only ever going up. So how is that going to change anything? That's not going to change anything. Come on, just magically be fast enough. I'm hoping it's close, and just like a tiny little tweak is going to push us over the edge. This is not giving me confidence. Oh, shit. Okay, I was not expecting that. Two. Imbecile. Absolute moron. Okay. Accumulated list equals get rid of this. Accumulated list equals accumulate RA, right? Now, if has changed, then accumulated list equals that, otherwise already ready. Okay, has changed is false, has changed is true. So I added this test case, right? Zero, zero. No, it's supposed to be 0, 1. What, it's still wrong? $15, 115. Okay, yeah, that's definitely the right one. And I made the change, right? So if it has changed, we regenerate. But we're still using the new tot. This was passing before. Oh. Sorry. 0, 1. Right. Okay, let's actually try it. I'm hoping that whatever's timing out is regenerating the same query multiple times. And this will give us just the edge that we need. No, it's the same one. It is the same damn thing. Well, I tried. This was literally my only idea. I thought it was a pretty good idea. I mean, I guess I could try to convert this to Java or something and see if that. I'm not going to do that. I am not going to do that. Well, that sucks. Okay, see ya.